Greetings, everyone. My name's Kunai, your average everyday talking blade. How is it that I can talk? Let's not delve into that subject. Anyhow, this video is but part one of the many adventures I had with my master Genji. So, without further ado, let me regale you with a tale that had happened a long time ago. This here is my master Genji. From when he was a 10-year-old through his adolescent years through today, he would always stick his nose in various books, and his favorite subject, physics of all things. At the time, he was just a college student, but he did partake in a part-time job of performing trick shots with me. As I recall, our first trick shot was on a Friday night in some assembly area. We got some volunteer to stand with an apple on his head, and so Genji threw me without any spin. Needless to say, I hit the apple spot on. Now how exactly did Genji knew how to throw me without killing the volunteer? You see, I was used as a projectile, an object that travels through the air via being thrown. So I was thrown just above Genji's head through what is known as a trajectory, which is a pathway for thrown objects. This is what most people call projectile motion. If we take a closer look, I was thrown straight in the air horizontally across what is known as the x-axis. Fun fact, if there was no gravity, I would be flying straight at a constant velocity with only the velocity Genji gave me. But since that ain't the case, I slowly was being pulled down. Also, there's air pushing past me while I fly, which is known as air resistance, but normally that's ignored for specifications. Plus, it tickles. On the other hand, we have the vertical y-axis, which is where gravity is most prominent. It's also important to note that gravity pulls down objects at an acceleration of 9.8 meters per second squared here, and no velocity is normally applied on the object when thrown, unless you're angry. Moving along, the volunteer was a little shaken up, but other than that, the audience loved Genji, and I had fun flying. The days would wane until the manager of the assembly area would confront Genji about the low sales in his performances. In short, the manager would sack Genji if he didn't pull some amazing trick shot to woo the crowd. So for the next few days, Genji would draw up plan after plan until he finally plotted the perfect trick shot to perform. On the day of the performance, a large audience formed, and needless to say, I was blown away. The plan was for Genji to throw me with a spin this time so that my sharp area could give the extra momentum needed for me to overcome the wall and hit the target. This is actually how most knife throwers throw knives, for that extra power and accuracy. Anyhow, this is how it all went down. 72 degrees. That's good, Genji. Woo! 18 meters per second. This is gonna be fun. Wait, 16.5 meters? Oh no. My velocity reached 0. Oh no, this will be close. Touchdown! Yay! I was expecting the crowd to boo him, but in the end, everyone loved Genji's performance and didn't seem to notice the mistake, so I was relieved. Some of you probably are wondering how that trick shot worked, which I doubt. Let's get into that. You see, ideally, these are the variables Genji wanted. I was to be thrown at an angle of 72 degrees at an initial velocity of 18 meters per second. When thrown at an angle, you need to know the components of the x and y axis. Because I was thrown above both axes, so it is important to note my velocity on each side, which can be calculated by multiplying the initial velocity with cosine theta for x, and for y, multiply the velocity initial with sine theta. Now the height needed to overcome that 10-meter wall can be calculated with this equation. Delta y equals negative initial velocity squared divided by 2 multiplied with 9.8 meters per second squared. Also, it's important to use the y-axis value since I did travel through it mostly. Then finally, the time it took for me to overcome the wall can be calculated with this equation. Time equals to initial velocity divided by 9.8 meters per second squared. Again, use the y value of velocity. The entire time of that trick shot took can be calculated by multiplying the previous answer with 2. With all those calculations, they equate to the ideal trick shot Genji wanted. So now comes my question. What variable affected the trick shot? I was supposed to land in the center of the target, but I landed way off. So you see, different angles and initial velocities can really bring different results. Like for instance, the best angle to shoot a basketball is 45 degrees and shot with a velocity of 4.4 meters per second. Or throwing a javelin at 45 degrees with an initial velocity of 0.98 meters per second is considered ideal. So go on and try yourselves on what angle and power is benefiting for whatever it is you want to throw. But make sure you're in a safe, controlled environment. Anyhow, I hope you liked the story and hopefully more is to come in the future. So for now, goodbye fellow viewers.